My name is Dr. Eric Turner. I'm with the Portland VA Medical Center and Oregon Health and Science University in the Department of Psychiatry and also in the Department of Pharmacology. And I'm a former reviewer at the FDA, worked in the psychotropic drugs group at the FDA, so involved in the approval process for new drugs and that were coming along, that drug companies were bringing along and hoping to bring onto the market. What I decided to do in this study that is published in the New England Journal, I decided to look at, me and my group decided to look at antidepressants and see whether there is a possible disconnect between what's in the published literature and what the FDA is reviewing. My experience, having been at the FDA, was that there were a lot of studies that I was seeing some studies that were not positive. And that had not been my experience in looking at the published literature. So it raised the question of whether there might be some selective publication going on. Were there studies not being published at all? Or might there be some studies published where the FDA might have one version of the results and what's presented in the journal articles is somewhat different? So we actually looked at that in this study. We got through the Freedom of Information Act reviews on FDA review documents on 12 antidepressants going back to about 86, beginning with Prozac, and up through duloxetine, which was approved only a couple of years ago, duloxetine being Cymbalta, an Eli Lilly product, 12 drugs, and we looked at all the trials that, according to the reviews, were conducted on these drugs, and then identified the studies within those clinical trials programs. We found a total of 74 studies for the 12 drugs, and then followed those studies to see what the fate of them was in published form. And we found overall, if we look at the first slide, we see a breakdown of positive versus not positive studies according to the journal articles and according to the FDA reviews. So if we first look at the journal articles, we see that virtually all the published articles, 94%, according to our way of judging whether they were presented as positive or not, were in fact presented as positive. So 94% presented as positive in the journal articles and only 6% presented as not positive. However, if you then look at the FDA version of the same clinical trials programs, you see that the split between the positive and not positive trials is really pretty close to 50-50. And you see that there's a larger number of trials. There's actually 74 trials overall. So then we might look at the next slide. Now we can see kind of a blow up in these two pie charts to the right side of this, a blow up of the positive trials and the blow up of the not positive trials. So among the trials that the FDA considered to be positive, they were in published form published as positive, with the exception of one trial, which was, somewhat curiously, not published. Now, but generally they were published in a way that agreed with the FDA's conclusion. The FDA felt they were positive, publication showed them as positive. Now, on the other hand, if you look at the negative trials, or the, shall we just say, not positive trials, and you blow those up and you break those down according to how they were presented in the journal articles, you see that only 8% were published in a way that agreed with the FDA's conclusion. In other words, it was acknowledged in the publication that the trial did not go well. There was another 30%, 31%, 11 articles that were published in a way in which, and these are trials that were not positive, but on looking at the publication, it appeared to us that the apparent outcome was a positive outcome of the trial. And then the remainder, and that's about 60%, 61%, 22 trials were just simply not published. And when I say not published, I mean not published in a standalone format. In other words, there wasn't a separate journal article devoted to the trial in question. Now, the other thing on the next slide, we have a look at, we looked at this in terms of the proportion of positive versus not positive trials. And we also looked at it in a more statistically rigorous way, which was looking at effect size. And effect size is a tool used by meta-analysts, and it gets around some of the problems with using p-values. P-values, such as p less than 0.05, p greater than 0.05, are can be subject to manipulation, if you will, by adjustment of sample size. If your sample size is too small, your p-value could easily be could be large and greater than 0.05, when in fact you may have a difference that is clinically important. On the other hand, if you could have a trivial clinical difference, and by driving up the sample size, you then have a difference that is statistically significant but not clinically significant. So looking at effect size gets around that. So combining the studies for each of these drugs, we have on this slide the 12 drugs, and this is another version of a figure that's in the journal article. We have the effect sizes according to the FDA, and then an added apparent efficacy due to selective publication. And you can see that for each of the 12 drugs, the apparent efficacy was greater in the journal articles than it was according to the FDA-derived data. And in the, I don't show that here in this slide, but in the journal article, we show what they went through in terms of a percent change, and the percent change for the drugs ranged anywhere from 11% up to 69%. Overall, if you take the group as a whole, the percent increase was about 30%, 32% to be exact. So about a third increase in apparent efficacy. So, and what do these effect sizes mean, you might ask? Perhaps it sounds esoteric, but there's some rules of thumb that were proposed by the father of meta-analysis, Jacob Cohen, and it could be argued as being somewhat arbitrary, but it's the best arbitrary rule that we have, and no one has come up with a better one. And effect size of, as you see on the slide, of 0.5 corresponds to is considered a medium effect size. 0.2 is a small effect, and 0 is essentially no effect, equal to placebo. So, and you can see that most of these drugs are in the range of in between small and medium, and so that'll just give you an idea. So I'm not saying, I just want to clarify, we're not saying here through this study that these drugs are ineffective. Each one of these 12 drugs, when we subjected them to meta-analysis, did prove to be superior to placebo to an extent that was statistically significant. But it's just that the magnitude of the increase, the magnitude of the advantage over placebo is less than might be thought based upon the published literature. So again, we're not saying that the drugs are ineffective, they're just less effective. And if you want to look at it in terms of the percentage of positive trials that we were talking about on the first two slides, it might be tempting to think of the drugs 50-50 as being basically a coin flip. It doesn't quite work that way. Again, the drugs are effective, but they're just less consistently effective than it would appear from the published literature. There's recent legislation aimed towards addressing the problem of publication bias, and is called the FDAAA Act of 2007. The studies will not only be registered, but there will be the FDA will be putting up its data in a kind of a condensed synopsis format after the trial is completed.